All right, let's just jump right into it. Today, we're talking about something pretty mind-blowing. Imagine peering all the way back to the dawn of time itself. Well, the James Webb Space Telescope did just that. And what it found? Well, it's pretty much rewriting the rulebook. It's pushing the absolute limits of what we can see and what we thought we knew about the universe.
So almost as soon as the JWST powered up and started sending back its first pictures, it started finding, well, puzzles. And one of the biggest mysteries came in the form of these objects that astronomers started calling little red dots. They were tiny, they were ancient, and they were shining with an intensity that it didn't make any sense. So what on earth were they?
You can think of this whole thing as a cosmic detective story. See, the JWST was built specifically to look back into the universe's infancy. It's baby pictures, really, a period we know very little about. And boom, right away, it starts finding things that, according to our theories, just shouldn't be there. These puzzling new objects had astronomers scrambling for answers.
And we're not talking about just some blurry smudges. No, these were intensely bright, super compact galaxies from the very, very early universe. The reason they look red, by the way, is because their light has been stretched out over billions of years as it traveled across space to get to us. And among all of them, one specific dot, a galaxy named Kuiper's LRD Z9, really stood out. It became, let's say, prime suspect number 1.
This brings us to the real heart of the problem, the central puzzle of this whole discovery. The brightness of these galaxies wasn't just a little off. It was a huge problem. It completely flew in the face of our most fundamental models of how the early universe is supposed to work.
So on one hand, you've got our scientific models. They tell us a galaxy this young, this early in the universe, simply couldn't have formed enough stars to shine that brightly. It's just not possible. But then, on the other hand, you have what JWST actually saw, a galaxy blazing with impossible light. The two just didn't add up. Clearly, we were missing a huge piece of the puzzle. And that leads to a pretty obvious question, right? If it's not a ridiculous number of stars, what else could possibly be powerful enough to outshine an entire galaxy? Well, the leading hypothesis was something way more extreme. A supermassive black hole at the galaxy center, just feeding on gas and dust and blasting out enormous amounts of light and energy. Okay, so the hunt was on. They had a strong suspect. A team, led by Anthony Taylor at the University of Texas at Austin, knew they needed to find the smoking gun. They had to prove, somehow, that a black hole was hiding at the heart of this mysterious little red dot.
Their main tool for this detective work is a technique called spectroscopy. It's actually a pretty cool 3-step process. First, you aim the JWST right at the galaxy and just collect all the faint light you possibly can. Step 2, you split that light into its different wavelengths, creating something like a cosmic rainbow. And then for step 3, you analyze that rainbow, looking for one very specific clue: the signature of gas swirling around at insane speeds. That is the telltale sign of a black hole's immense gravity.
And this is the aha moment, the discovery, the smoking gun. As the lead researcher Anthony Taylor put it, there aren't many other things that create this signature, and this galaxy has it. Just like that, they had their proof. The impossible brightness wasn't from stars. It was coming from a ravenous black hole. So, with the black hole confirmed, the next logical question was, okay, what kind of cosmic monster did we just find? And let me tell you, the details that started to emerge were absolutely staggering. They were setting new records and just shattering old theories left and right.
First off, the age. Get this. This black hole was already a monster just 500 million years after the Big Bang. That's when the universe was just 3% of its current age. We are literally looking at the dawn of time here.
Then there's its incredible size. The team estimates its mass could be up to 300 million times the mass of our own sun. That is a true heavyweight champion for that early in the universe.
But here it is. Here's the detail that just breaks everything. That colossal mass, it makes up nearly half of the mass of all the stars in its entire galaxy combined. Now, for comparison, the black hole in our Milky Way is a tiny, tiny fraction of a percent of our galaxy's mass.
This wasn't just a black hole in a galaxy. This was a monster basically wearing a galaxy like a hat.
This chart really puts that shocking ratio into perspective. The black hole and its host galaxy are nearly equal partners in mass. It's not just an anchor at the center, it's a cosmic titan that's dominating its tiny little home. This is completely alien to how galaxies and black holes coexist in the universe we see today.
So, what does this all mean? I mean, finding the oldest black hole is more than just a new entry in a record book. At Discovery this extreme forces us to go all the way back to the drawing board and completely rewrite our understanding of how the very first things in the universe even came to be.
Our old models simply can't explain this. It's impossible. So the discovery forces us to consider two pretty radical new possibilities. Option 1, maybe the first black holes were just born big, starting out way more massive than our theories ever predicted. Or option 2, they grew with ferocious speed, gobbling up matter much, much faster than we ever thought possible. And you know, this isn't just a one-off weirdo galaxy. As study co-author Stephen Finkelstein points out, this is just part of a growing mountain of evidence. The JWST keeps finding things in the early universe that are bigger and more developed than they have any right to be. It suggests that the dawn of the cosmos was a far more violent and rapid process than we ever imagined. And that leaves us with this final, really thrilling question. By solving the mystery of the little red dots, we've actually uncovered a much deeper one. If black holes could get this big, this fast, so early on, what other fundamental things have we gotten wrong? What else don't we know about the dawn of our own universe? For now, we can only wait for the next amazing postcard from the beginning of time.